plant produced 1.5 billion rounds last year. The plant makes all small caliber rounds used by the Defense Department. It's the largest producer in the United States. But it's no ordinary factory. Here, the process begins with soft metal and a deep sense of purpose.
The key to our success here is not necessarily in all the machinery in the buildings and the infrastructure, but in the people that work and make our product that goes out to support the warfighter.
We want to make the best ammunition to support the troops, and I think that we as Lake City take great pride in what we do. I really feel that it's important that we make good quality product, because we have relatives over there, we have friends over there, and I really feel that we do good quality work, so when they go out there on that field, they know that they have good product from this company.
The Lake City Army Ammunition Plant has been making bullets since World War II. In between wars and conflicts, there's always a training mission, so the plant stays in business building reserves and stocking units around the world with training rounds for M16s, M60s, and aircraft guns. Quite frequently, the end users of the product find themselves continuing their ammo careers on the line at Lake City.
Most of my colleagues have their MOSs or their job specialty in the service, whatever branch they were related to the ammunition field. So there were ammo techs in the Army, or there were ammo techs in the Navy, or ammo techs in the Air Force. In fact, we have one of each right now currently in our staff.
A quarter of our workforce is former military. A good majority of the workforce have current service members serving overseas. We've got grandmothers, grandfathers, fathers, mothers, aunts, uncles, and it's easy to attribute what they do day in and day out to what they're providing and the mission that we do with the small caliber rounds. And so I think that's something easily grasped by the employees here, and they take great pride in what they do every day, from a maintenance guy all the way down to the folks that are packing and transporting the rounds.
Whether they have served in uniform or not, the folks at Lake City have forged a bond and a mutual respect for the product they make and the person who pulls the trigger.
I feel good because I do the best that I can, because I know that they're fighting for me overseas, and no junk comes out of here.
From the Lake City Army Ammunition Plant, I'm Pam Proper for the Pentagon Channel.
Almost all bullets, though, are literally the tip of a much larger self-contained package. The bullet is the projectile part of a cartridge. Traditional bullets usually have lead cores, covered by a hard jacket of copper or brass. The bullet is gripped at its base by a brass casing, which also holds the propellant and the primer. The propellant inside the casing is smokeless powder, finely granulated nitrocellulose. The copper or steel primer cup at the base of the casing holds an explosive, which is pressure sensitive. The fully assembled bullet and casing is a cartridge, or round. Whether used in a single-shot weapon or one fed by a magazine of ammunition, each cartridge must be cycled through the weapon and fed into the chamber.
The chamber is where the combustion takes place. When you pull the trigger, the firing pin hits the primer. The primer contains a very small amount of explosive compound which produces a flame. Flame goes through a small hole in the base of a case and ignites the powder charge. The powder charge burns, does not explode, it burns, and it moves the bullet out the barrel and also gives it a twist, usually a right-hand twist, and that twist is what stabilizes a bullet in flight. Sounds simple, took about 500 years to figure out.
The development of the bullet was slow compared with the pace of improvement in the weapons that fired them.
The earliest projectiles would have been stones, rocks, something that was thrown by hand first. The caveman would have evolved from basically throwing stones to perhaps the ATL, which is basically a spear projectile, eventually moving into projectiles that were used oftentimes on shafts, that is, as javelins, as arrows, as a spear, and also as hand arms, darts.
Around the 9th century, the Chinese invented gunpowder. Firecrackers scared off demons. Simple rockets provided delightful spectacles and were also used as primitive weapons.
The Chinese soon learned that they could also project projectiles out of tubes. Some of the first firearms were nothing more than a bamboo tube with a polished rock and some gunpowder thrown in the bottom.
It took hundreds of years for the secret of gunpowder to make its way to Europe. It wasn't until the 13th century that Europeans began experimenting with it and its uses. Soon after, they were producing the first handguns and the world's first real bullet, the round lead ball.
The history of the round lead ball basically spans centuries. Part of the reason for that is the round projectiles would have been easier to load into the barrel than others. They're also possible to standardize in terms of weight.
Lead is a commonly occurring metal found around the world. Its low melting point makes casting lead balls an uncomplicated low-tech process. Using the simple lead ball, however, was complicated, slow, and unreliable. The gunner had to pour black powder into the smooth metal barrel, then ram the ball into place. Next, he had to prime the flash pan with a small amount of powder. After all this, when he pulled the trigger, the gun didn't always fire, because the powder didn't always burn.
If it got wet, it was totally useless and it was hard to keep it dry. Napoleonic-era armies rarely fought running battles in the rain.
Another even more serious problem was fouling. The buildup of residue in the smooth metal barrel, burning gunpowder, and lead from round balls left heavy layers in the barrel, quickly rendering the gun unusable.
And in a time of battle where you can be expected to fire 40, 50 rounds during a one day's engagement, after 10 rounds your gun may become completely useless to you if you're not able to clean out that burned up fouling.
With nothing better to replace it, the round lead ball ruled for 5 centuries. Then, in the 1800s, over a period of less than 50 years, 4 separate discoveries would come together to create vastly more effective bullets. The power and amazing versatility of today's bullets depend on 4 key developments, all of them occurring in the 19th century. The rifled gun barrel, the conical bullet, the self-contained cartridge, and refined gunpowder. The first step in revolutionizing bullet design was the introduction of the rifled barrel. Rifling is the spiral grooved pattern cut into the inside wall of a gun barrel. As the bullet speeds along the barrel, the rifling sets it to spinning.
We believe that rifled arms, though, were initially considered for an entirely different reason than they're used today.
The initial reason for rifling was probably to control the buildup of powder and lead residue, which resulted in fouling the barrel. The grooves held some of the debris, leaving the barrel a little cleaner.
There was a theory that some gunsmith cut spiral grooves in a barrel just to counteract the effects of powder fouling, and found by accident that it made the bullet spin, the ball spin, and that it was far more accurate. Without a grooved barrel, without a rifled barrel, we would have no accuracy at all.
In fact, rifling had little effect on the buildup of residue. The spin, however, increased the accuracy of the ball, but only slightly, particularly when wrapped in a cloth patch. It would be another 200 years before the development of an entirely new kind of bullet made truly effective use of rifling.
In the 1840s, a French ordnance officer named Claude Etienne Minet perfected a crude-looking bullet with a lead slug that had a hollow base. Because his bullet could be made undersized, it could be rammed down even a fouled barrel very quickly with no problems. But because the base was hollow, when the pressure of the expanding powder gas hit it, it would expand to take the rifling and spin accurately, and it was accurate even by today's standards. It was a huge, huge step forward.
You can think of it much as a quarterback throwing a pass. If he puts a nice spiral on it, the ball will go where he's intending it to go, and it will go a longer distance than if he somehow throws the ball where it's tumbling end over end.
Today we call it the mini ball. Little corruption of the French pronunciation, but a conical shaped bullet's going to fly through the air better than a round ball because a bullet is piercing the air instead of presenting a large face of resistance, so its friction is less.
By 1861, as America moved toward civil war, a deadly accurate long-range weapon with a fast-loading bullet was in the hands of the infantry for the first time in history. Commanders failed to grasp the implications, with catastrophic results.
The generals on both sides were indoctrinated with the tactics of Napoleon. Now, what Napoleon said you must do is line up all your troops in a row, cheek by jowl, and have them march in order toward the enemy, drums and bugles blaring, fire one volley, then fix your bayonets and charge.
That dissolved very quickly when you can sit back behind a stone wall and shoot at somebody 500 yards away and knock them down. And they won't even hear the shot fired at them before the round hits them.
Casualties on both sides were enormous because of the rifled barrel and the mini-ball. Perhaps the single worst slaughter occurred on July the 3rd, 1863, just outside a village called Gettysburg. In an assault led by General George Pickett, 13,500 Confederates marched in textbook formation directly into the blazing guns of entrenched Union forces. In about an hour, 10,000 Confederates were killed, wounded, or captured. The mini-ball fired from a rifled barrel helped destroy the Confederate wave, and arguably helped save the Union. Shortly before the rifled gun and the mini-ball proved their combined value, gun makers, including Samuel Colt, developed fixed ammunition for pistols, another of the four key developments. The first metallic cartridge was the pinfire, invented in France in 1828. A brass tube ran through the side to a percussion cap, which ignited when hit by the hammer of a pinfire revolver.
The invention of the metallic cartridge, in this country we have the partnership of Smith & Wesson to thank. I call it the 3 Ps, the primer, the propellant, the projectile, all in one. The 3 basic elements that you need to make a gun go bang and work are all self-contained.
At first, self-contained ammunition was slow to catch on. The weapons firing them were too few and too costly. But as weapons became available, metallic cartridges modernized the world of bullets.
The impact of cartridge firing guns really came after the Civil War with the appearance of firearms like the Colt Peacemaker and the Winchester Model 73. These were truly modern firearms. Reliable, simple, fast firing, and accurate. That's when it came in, from about 1873 onward.
In the late 1800s came the fourth and last innovation, leading to the creation of modern bullets.
The most important invention in the history of the bullet would have to be smokeless powder. Without smokeless powder, we would have nowhere near the velocity we have today. We would have nowhere near the rapid fire potential. Everything would be different.
Smokeless powder was more stable and predictable than black powder. and far more powerful.
The first smokeless propellants of the 1880s were chemically very similar to what we have today, being primarily nitrocellulose compounds, a mixture of cellulose, nitroglycerin, and certain nitrates that made it possible to come up with smaller, elongated, jacketed bullets driven at very high velocity.
A mini ball could be fired at maybe 1,200 feet per second with black powder. With smokeless powder, you could get a smaller slug moving at literally twice that velocity.
The combination of the rifled barrel, the conical projectile, smokeless powder, and self-contained ammunition gave bullets unprecedented accuracy and power. The bullet continued to change to meet new demands. Late in the 19th century, Hiram Maxim's rapid-firing belt-fed machine gun worked best with a bullet tailored for it, pointed and more slender.
Now we can fire guns at rates of 600 and 800 rounds a minute, where before in the Civil War it was 3 rounds a minute.
The murderous efficiency of the machine gun and the new bullet was proven on the battlefields of World War I. In a deadly escalation, the British developed the tank to protect their troops from machine gun fire. To defeat the tank, the Germans created the first armor-piercing bullet, the German J round. A 13mm or 50 caliber armor-piercing bullet gave them a chance against behemoths of steel.
You could have 2 men armed with this gigantic rifle firing armor-piercing rounds at British tanks and put them right out of commission fairly quickly.
The armor-piercing rounds were created by inserting a solid core of steel into the center of conventional bullets to keep them from crumpling when they hit a tank. In a later development, this core was reinforced with a nickel-cadmium plating. Even the most devastating bullets are useless if they don't hit their target. To help gunners see where their rounds were going, Army Ordnance officers looked back in history to the Civil War for answers.
Being able to visually identify where your projectile is in flight easily have developed from lubricant used on various projectiles of the black powder age. Sometimes they would leave a little smoke trail as the bullets went downrange.
Smokeless powder had eliminated the trail, so the tracer bullet was created by attaching a pellet made of magnesium and phosphate to the base of an ordinary bullet. When the bullet is fired, it is clearly visible. Usually every 5th round is a tracer. Military bullets have undergone numerous refinements over the years, but their basic design has remained much the same since World War I. Lead cores wrapped with copper, known as the full metal jacket. Most bullets today are far better than they were 20 years ago, much better than they were 10 years ago. While some are deadlier than their predecessors, others actually offer the chance to save a life rather than take one in a shooting. The challenge is determining which to use in what situation. Bullets today come in hundreds of different sizes, shapes, and weights. Determining which works best depends entirely on what the shooter wants the bullet to do when it hits the target.
The target is everything. The bullet is designed for the target. You can shoot holes in paper, or you can shoot holes in 1/4-inch mild steel armor plating. You can hunt elephants, or you can hunt squirrels, and you can't do all of that with the same cartridge.
Police need to be able to stop a dangerous suspect. Soldiers need a bullet that will penetrate an enemy target. Hunters want to kill their prey as quickly as possible.
As an example, the .22 short, as fired out of this rapid-fire pistol made by Benelli, is probably only powerful enough to punch a hole in a piece of cardboard on an Olympic target. On the other hand, the .45 Long Colt, with its 250-grain solid lead bullet, as fired out of the Smith & Wesson Model 25 revolver, is certainly powerful enough to stop a human being.
In the world of bullets, size matters. Size is the diameter as expressed in caliber.
When we're talking about caliber, what we're really discussing is a measurement of the diameter of the bullet itself, usually described either in millimeters or decimal inch.
American ammunition makers usually measure diameter in fractions of an inch. A .22 caliber bullet, commonly referred to simply as a .22, measures 22 1/100ths of an inch in diameter. The U.S. military usually calculates caliber in millimeters rather than fractions of an inch. Thus, their long version of the .22 caliber round is designated as a 5.56 millimeter. The long and the regular .22 round have the same size bullet. It's the casing size that varies.
For example, the .45 Long Colt caliber cartridge has a bullet diameter of .451 or .452 in its modern loading, which is the same as the .45 ACP cartridge as loaded for the old .45 government model automatic pistol. As you can see, they're two completely different cartridges, but the same caliber.
The longer the cartridge, the more powder it holds. The more powder it holds, the faster you can drive the bullet. The faster you can drive the bullet, the more energy it builds up.
The basic rule is, the bigger the target, the bigger the bullet needed for optimal effect. Less powerful bullets with short cartridges, such as the .22 and the .25, are used mostly for target practice. Police and military prefer medium caliber pistol bullets, such as the .45, powerful enough to stop an aggressor without continuing through to hit bystanders. The larger the round, the greater the amount of powder propelling the bullet. Military and police snipers typically use a .308 or larger caliber rifle bullet to achieve instant disabling of the subject. The round's higher velocity also makes it more accurate at great distances. The size and power of the bullet aren't the only factors that affect what happens in that critical moment when the bullet hits the target. The bullet's shape, as well as the materials used to make it, affect its performance.
If you are going for a long range, you need to make the bullet streamlined. If you're going for maximum tissue damage at short range, you can have the bullet be blunt or hollow.
On impact, the jacket of a hollow point instantly peels back, exposing the soft lead core, which then expands against the target.
Modern bullets use a hollow point design, which is designed to mushroom, and what this does is it makes the front surface area of the bullet much larger, transfers much more of the muzzle energy to the suspect.
A solid-nosed bullet penetrates a soft target more easily because of the hard copper and zinc alloy wrapped around the soft lead core. Used by NATO military forces, this is the bullet known as the full metal jacket.
We're basically restricted to the standard ball round. Industry offers expanding bullets, flattening bullets, mushrooming bullets, but law of war, the Hague Convention, restricts us to rounds that will not induce undue suffering to the combatant.
In recent years, because of environmental concerns about lead, the U.S. military has changed the lead cores used in its bullets. Hundreds of live-fire training sites and civilian firing ranges across the country have been closed because of lead contamination.
Lead causes birth defects in children. It can cause memory loss. Lead has a bunch of very negative environmental aspects to it.
It's an environmental issue, and it's one of our major concerns is cleaning up the ranges that have been contaminated with lead. And one of the efforts the Marine Corps is taking right now is to overhaul our small caliber ammunition and transition from lead to a tungsten nylon projectile.
The lead-free replacement is called the green bullet, which is also a frangible. Tests confirm that while it is environmentally friendly, it's just as lethal on the battlefield.
And that was one of the things that we made sure that we were going to do before we fielded a green round, is to make sure that we were getting the same product minus the lead.
For all U.S. forces, replacement of lead core bullets with those made with tungsten, tin, or nylon cores is scheduled for completion by 2008.
Since the matrices contain no lead, of course, you don't have the lead cleanup problem that was the environmental problem of the past.
In addition to the materials used to make it, a key factor determining the impact of any bullet on the target is its muzzle velocity.
Muzzle velocity is simply the speed or the velocity with which the bullet leaves the muzzle of the gun. It's the fastest it's ever going to go. From that point on, it will be slowing down.
Because of modern higher energy powders, the bullet's initial velocity can be as high as 5,000 feet per second, or 3,400 miles per hour.
No matter how streamlined you make a bullet, air resistance still works on it. Gravity affects it somewhat. If you held a bullet alongside the muzzle of a rifle and dropped it at the instant you fired, the bullet you dropped and the bullet you fired would hit the ground at the same time.
In recent years, high-speed cameras and computer models have greatly improved the ability to evaluate bullet performance. Complex equations help predict the effect of design changes. But there are still surprises in the firing range.
In the end, you have to get out and shoot the thing. A number of bullet companies have gotten pretty badly burned in the past because they designed something that looked great in the lab and looked great on paper but didn't work so well in the field. So you need about half scientific testing and about half real world.
In the real world, failure to use the right bullet can have deadly consequences. North Hollywood, California, February 28, 1997. The scene of the most violent shootout in modern American police history. For 44 minutes, two heavily armed bank robbers managed to hold off the best the LAPD could bring to bear. The robbers, using fully automatic assault rifles, unleashed a relentless barrage of high-velocity .223 and .308 armor-piercing bullets. The police fired back with everything they had, but their 9mm and .38 caliber bullets just bounced off the body armor worn by the criminals.
Standard issue was a .38 revolver or a 9mm automatic and a 12-gauge shotgun, neither of which will come close to coping with body armor.
By the time the carnage was over, nearly 2,000 rounds had been exchanged. 7 civilians and 11 police officers have been wounded. One suspect killed himself. The other bled to death after an LAPD SWAT team managed to hit him in his legs, which were unprotected by armor.
The North Hollywood shootout scared a lot of cops real good. It informed them very plainly that the weapons they were carrying on the job were not nearly big enough for some of the situations they had to handle.
For general police work, the solution was not to simply use a bigger bullet.
We can't use oversized bullets because it's just too much for an officer to control. We can't use undersized bullets that will never miss because then they wouldn't be very efficient on the person we're trying to stop anyway. The challenge we have is finding that balance between bullet design that's going to transfer as much energy as possible to the suspect and controllability for the officer so that the recoil is not so excessive that the gun is bouncing all over the place.
From the early 1900s until the late 1970s, the standard issue for police officers was the .38 caliber lead-nosed bullet. Often it lacked the knockdown punch needed to stop criminals in their tracks.
They wouldn't do much damage, and the person would literally be very unaffected by being shot by the round.
The search for a more powerful bullet led to the development of a fearsome new round, the .357 Magnum.
All .357 Magnum is, the truth be told, is simply a .38 special made longer, and Magnum simply means larger. The .357 Magnum is considered for the most part too powerful too much. And so we stuck with the .38 Special clear through the early 1970s.
Following a tragic 1986 Miami shootout in which 2 FBI agents using underpowered 9mm and .38 caliber bullets were killed, police agencies looked at the Army issue .45 caliber Colt.
For the average officer, that creates a lot of problems of flinching, anticipating that excessive recoil, and they become inefficient. They don't shoot well.
Then, in the 1990s, police around the country began settling on a bullet that best satisfied their needs, the .40 caliber hollow point.
We have a modern hollow point round that can fit in a small enough weapon that people can control it. The rounds are hitting the suspects, not going through the suspect and harming bystanders, and it's very efficient. And even the smallest, slightest build officers can control that weapon and have confidence that it's going to work for them.
Sometimes no off-the-shelf bullet meets a user's particular needs. For maximum performance, thousands of shooters hand-load their ammunition. Among them is a group of Marines at Quantico, Virginia.
At the test facility, what we're trying to do is come up with the most accurate rounds, obviously matched to the weapon.
The process begins with gunsmiths modifying standard issue weapons to meet special requirements.
For different guns, we have different requirements. We can't build a sniper rifle to the same requirements as a pommel rifle. The pommel rifle is used for match. The sniper rifle would be used for combat. And it's all about performance of the weapon with the ammunition.
The elements used to build the bullets arrive from manufacturers as separate components.
It's hard to do mass production of ammunition and keep the consistency there. That's why we weigh each projectile, where we weigh each casing, where we weigh each primer, and then we put it all together, and then we weigh it again for consistency. Consistency is the key to the perfect bullet.
Each bullet is tailor-made for the specific weapon that will fire it. An ammunition loader turns a next sizing brush all the way around the outside diameter to bring it down to a desired thickness for holding the projectile or bullet with uniform tension. He then trims the length to ensure it fits into the assigned rifle chamber properly, measuring it for consistent length for even release of the projectile or bullet. Another ammunition loader transfers a tube filled with explosive primers to a hand-operated priming tool. Then he individually inserts each primer in the base of the brass casings. The primer is the actual initiator for the powder charge that comes later. The next loader weighs each bullet in increments of 1/10 of a grain. In this case, the correct weight is exactly 142.0 grains, 1/3 of an ounce. These are set off to the side until the casing is charged with gunpowder. The Marine handling the propellant or gunpowder measures out the exact amount for each load. And then carefully pours it into place. With a firm, steady pressure, he finishes the round by fitting the bullet into the filled casing. His final measurement confirms that the round's overall length is precisely correct.
Then we package up the rounds with the load name that we assign it, the date that we produced it, the gun that ammo is actually for, and the quantity that's within that box.
Laboratory testing of random samples checks chamber pressure, velocity, and other performance characteristics. To simulate extreme weather conditions, some bullets are heated to 120+ degrees. Others are cooled to -25.
The ultimate goal is to give the shooter on the line the best possible weapon and the best possible ammunition married up to that weapon. We're trying to take all the errors that we can out of the process.
Final performance testing of the ammunition takes place on the firing line. The precision shooters conducting the trials are the Marine Corps' best, snipers and members of the Corps' national competition teams.
once the testing is complete through Precision Weapons, they will forward the results of those tests back to the manufacturer to where components will be made to that spec.
Whether hand-loaded or manufactured, most ammunition today is highly effective. But experts are on the verge of creating bullets that seem to think for themselves. Police and military would like a bullet able to punch through body armor and bring down the target, but not pass all the way through and hit an innocent bystander. Such a bullet seemed impossible. Until recently.
We offer in a single round the ability to defeat hard and soft body armor barriers and offer performance that only has been accomplished by frangible ammunition prior to our bullets.
To create the new ammunition, 8 metals are bonded together through a unique proprietary method. The difference between a conventional bullet and the new one is dramatic. Standard lead core bullets wrapped in copper jackets are stopped by metal and rip through flesh and keep going. The new bullet senses the steel, stays cool, and punches a clean hole through the target. Then, when it encounters body heat, it deprograms, becomes soft, and expands 360 degrees inside the tissue.
When we demonstrated the blended metal technology, we demonstrated the ability to defeat barriers and yet totally shred and destroy the tissue that it hits without the liability of having an overpenetration.
Quite possibly, had the LAPD been armed with the new bullets during the North Hollywood shootout, the outcome would have been completely different.
They would have been able to defeat the soft body armor. They could have eliminated the threat and neutralized the situation with minimal possibility of citizen injury beyond the initial threat area.
But the police prefer not to kill. They'd rather knock the suspect down, incapacitated, unable to resist but alive. Today's bullets aren't controllable in that way.
It's really an unfortunate side effect that the bullets that create the most damage are also the bullets that kill us. If the damage could be separated from the lethality of bullets, we'd probably be more humane.
In the near future, though, the police may well have the option to kill or to stun with the same weapon. In development now is a multiple-barreled pistol called the Variable Lethality, or VLE, handgun. It will give police a range of options.
We can fire a less than lethal round in one barrel, a lethal round in another, a 9mm, a 45mm, a 15mm beanbag, a pepper ball round. It doesn't matter, which means I can fire a non-lethal or automatically switch to lethal if that's required.
The VLE handgun cannot be fired by just anyone who gets his hands on it. A computer chip embedded in the handle has to match a coded finger ring.
Anybody that is not intended or authorized to use that gun can pick it up. It will not fire. And if they attempt to make it fire, the computer and the chip will basically fry itself and it'll never be useful.
The manufacturer of the VLE handgun has also created a cartridge that has no shell casing and no primer. The gun that fires the bullet has no trigger, hammer, or breech block. The only moving parts are the bullets, thousands of them a second, going down the barrel.
Metal Storm technology basically is the ability to stack multiple projectiles in a single tube or barrel, stack them nose to tail, and electronically fire them one at a time from front to rear.
It is done with a computer, so the rate of fire can be anywhere from 1 round or up and over to over 1 million rounds a minute. Today's fastest weapon, mechanical weapon system, can only burp out a rounds at about 6,000 rounds a minute, max.
180 Metal Storm bullets have been fired out of 36 barrels in a fraction of a second. If that rate of fire could be sustained, that's slightly more than 1 million rounds a minute. Bullet technology is constantly evolving, preparing for what it calls the future combat system. The U.S. Army is experimenting with a bullet that can be fired around corners, travel a predetermined distance, and explode. The bullets come in two calibers, the standard NATO 5.56 millimeter round and the high explosive air bursting 20 millimeter. The XM29 locks on target using a laser rangefinder with day and night optics. Target information is automatically communicated to the chambered round. A microscopic digital chip in the round programs itself for distance and trajectory, then ignites the projectile, sending it downrange to burst precisely on target.
It's programmed to go X number of meters and then explode downward. So the poor devil who's hiding in the hole, thinking he's safe, is going to get a bad surprise.
The 800-year history of bullets has been one of slow progress, interspersed with occasional sudden waves of dramatic development. But since the 1990s, better metallurgy, new manufacturing processes, lasers, and microcomputer chips have generated more technological advancements than those of all the past hundreds of years combined. Still, the greatest advancement in bullets may eliminate killing altogether.
If there was a magic bullet where we could shoot someone and they would live every time, but they would stop immediately, we'd buy it in a heartbeat. The equipment we have has limitation, and we're hoping that science is going to bring us something that's going to work better, make us safer, and make people stop sooner, because stopping is what we're after.
So while the lethality of the bullet increases,